inverse variation. What happens with inverse variation or indirect variation is that you have the same setup, but now instead of the x being in the numerator, if something varies inversely, then that means that the factor that follows is going to be in the denominator of a fraction. Okay, so you're going to follow the same exact steps, but here when you see y varies, so that's going to start out as y equals k times something. When you see it says inversely with x, what that means is you're putting a fraction bar, and you put whatever comes next in the denominator. So y equals k over x is going to be the general form here. Once you get your form, you're going to plug in your x and y. So I get 1 over 54 is equal to k over, and plug in my x value, 12. So if I multiply both sides by 12 to get k alone, I'm going to solve for my k value. Here 6 goes into 12 twice, 6 goes into 54, 9. I get 2 over 9 equals k. And that gives me my equation, y equals 2/9 x. So there's the equation that I derive. Once I have my equation, I'm going to reevaluate when I solve, or when I plug in the 9 here, I get 2 over 9. And remember, this was, let me go back to this equation part. Okay. When I evaluate this, I get, or when I rewrite my equation, I get y equals, and my k value is 2 over 9, and my x is in the denominator. So the equation that I get has that variable in the denominator. So when I test for this negative 9, plug that into x, I get 2 over 9 times negative 9. And when I simplify what I have, I get 2 over negative 81 as my solution. Right. So the inverse variation just tells you when you're reading the problem, y varies, so y equals k times inversely, so k over the square of x, so x squared. So here's your basic form. What you can then do is plug in the numbers for those. When you plug in the known y, which is negative 1/9, set that equal to k over x, which is 9 squared. So I'm going to multiply both sides by 9 squared. Now, the reason I'm choosing 9 squared instead of 81, it just, when I look here, this 9 cancels with one of those, so I get negative 9 is equal to my k value. And when I solve for this and write it in my equation form, y is equal to negative 9 over x squared. Make sure you have your equation written correctly for that. And then to evaluate y of negative 8, when I plug that in, negative 8, this whole quantity is being squared, so I get negative 9 over 64. Nothing cancels between those two, and that would be my solution. Okay, the next example has y varying, so y equals k times something. Inversely means divided by the cube of x. So there's my equation. Plug in my values. 11 over 64 equals k over negative 2 cubed. So to solve for this, I'm going to multiply both sides by negative 2 cubed, which is negative 8. Those cancel, and I get 8 goes into 64 8 times. And so I have negative 11 over 8 for my k value. So I can write my equation, y equals negative 11 over 8. It's an inverse, so my x is in the denominator cubed. So there's my equation. When I evaluate with x being 3, I get negative 11 over 8, 3 cubed. And if you multiply this through, you get 3 cubed is 27 times 8 is 216. So I get negative 11 over 216 as my solution.